everyone, students, welcome to our channel Deeksha Karnataka. So we have been receiving a lot of messages from you that ma'am, you are focusing only on PU2, only on KCET. Please do something for PU1 as well. Okay, and we thought that this is the right time to help you or to boost your preparation, because we know that you are going to write your final exams in few days. So yes, in today's video I'll be discussing the PU1 model paper of chemistry that is released by the Department of School Education, that is pre-university, by Government of Karnataka. Okay, so solving model papers can actually help you to boost your confidence, can test your level of preparation, and it might happen that some similar questions can be asked in the final exams as well. Okay, so it is very important to see or to solve the model test paper. So it is my request to all of you to download the question paper and first solve it in a 3 hours period. Give yourself time setting practice. So 3 hours you take and solve all the questions that is possible. Then after that, come and watch this video and you can know what mistakes you have done, what you should have written, what went wrong, what is the correct approach of solving the numericals and all. Everything I will discuss. But first please solve the paper and then watch. That will be more beneficial. Okay, but if you do not have time, you can watch it directly as well. Okay, so let us discuss about the question pattern here. So you have okay, so in question in first part there are 5 parts in the question and all the parts are compulsory, so you have to write all the parts question. So in part A there are 20 questions where we have 15 MCQs and 5 fill in the blanks, and all the questions are compulsory. Okay, now coming to part B, there are 2 marker questions. You have to attempt any 5. Okay, so 5 questions if you attempt, you will get 10 marks. Now coming to part C, which has 3 marker questions, there you have to write 6 questions. Okay, so you will get 18 marks from there. Then you have part D, where you have to attempt 5 marker questions. You have to attempt any 2 and you will get 10 marks. Okay, so next coming to part E, that is 12 marks, where you have numerical questions. So you have to write or solve any 3 numericals. You will get 12 marks there. Now here something which is very important is in part A, first attempted questions will only be considered for awarding marks. Okay, so if you write crisscross the answers, if you write first you write A, then you cross it and then you write B, then it will not be evaluated. So make be very sure that if you are 100% confident on the MCQs, then only attempt it, or you can leave some space later after you have written everything. You can think about it and then you can write down the answer. Okay, but in MCQs please do not do any mistake in the first attempt. Okay, now chemical reactions, generally you have to write the balanced chemical equations. Okay, and you should draw, if any diagram or any graph you have to draw, you have to level it as well. Okay, yes, now direct answers to the numerical problems without detailed steps and specific units will not carry any marks. Okay, so whenever any numerical is there, you have to follow 3 steps. First is what? You have to write the formula. Second, you have to substitute the values correctly. Third, you have to write the answer with units. Okay, so let us move forward now with the first question. So we have 1 marker question. So the first question here is that the prefix used for multiple of 10 to the power of minus 6. So we know for 10 to the power of minus 6 we use micro. Okay, for macro, for nano it is 10 to the power of minus 9, and for milli it is 10 to the power of minus 3. Macro is in general we say to very big molecules. Next question, if 2 volumes of gas give 1 volume of A2 and 1 volume of B2, then the molecular formula of the gas will be. So we have 2 volumes of one gas. Okay, and when it dissolved or when it decomposed, you got 1 molecule of A2 and 1 molecule of B2. So this is the only reaction I can write here. Okay, so if I write A2B2, okay, so I cannot take 2 molecules of A2B2. See, if I take 2 molecules of A2, then I will get 2A2 plus 2B2 to balance the reaction. But they are saying that we are getting 1 mole of A2 or 1 volume of A2 and 1 volume of B2. So that is why this option is incorrect. A4B4 also same. If you take A4B4, then you will get the same this side. So this is also incorrect. So the correct answer is AB, and the answer for this one is only 3, option number B. Now next question, An atom of an element contains 19 electrons. Its nucleus has 20 neutrons. What is the mass number? This is very simple question. See, mass number is equal to the sum of the protons plus neutrons. If the number of electrons is 19, okay, then I can say the proton is also 19, and because it is a neutral atom, okay, and the neutrons are 20. So what's the total number or mass number? 29. That is option number A. Okay. Next, the chemical properties of an atoms are controlled by the number of. So the chemical properties depends on electrons. So that is option number C. Next, choose the correct order of atomic and ionic radii of chlorine atom and chloride ion in ppm. So this is like very factual data, okay, so you should remember for chlorine the values, okay, but generally such type of questions are not expected where you have to remember the values. So for chlorine it is 90 and for chloride it is 186. Next we have the valency of noble gases. We know they are unreactive, so it is 0. The conversion of O2 to O2 plus involves the removal of electron from. So if I write the electronic configuration or molecular orbital configuration of O2, what is it? Sigma 1s. So how many electrons are there? We have 16 electrons, right? 8 plus 8, 16. Sigma 1s2. Then I have sigma star 1s2. Okay. Then I have sigma 2s2, sigma star 2s2. Then after this, in case of O2, what happens? First sigma 2pz will come, right? Sigma 2pz2, okay. After that we have, so 2, 2, 2, 2, 2. So I have already completed 10 electrons, right? 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Next I have, okay. Next I will go for which one? I will have pi 2px, okay, is equal to pi 2py. So here 2 electrons, here 2 electrons. So 10, 11, 12, 13, 14. So after that I have pi star 2px is equal to pi star 2py. Now because these are degenerate orbitals, you have to give 1 electrons each. Okay. So from where the electrons will be removed? From anti-bonding pi orbital, option number A. Okay. Next, the example of an intensive property. So what is intensive property? The property which does not depend on the amount of substance present, right? It is a intrinsic property of the material. So intensive property will be your temperature, okay, temperature. Then you can say like molar heat capacity, unit like specific heat capacity. These are your intrinsic properties or intensive properties. Next, coming to the change in internal energy for an isolated system when there is no transfer of energy as heat or as work will be equal to. So if you know delta W is equal to delta U is equal to Q plus W, right? Now Q is also 0, W is also 0, so delta U will be equal to 0. Next, statement based question. Equilibrium is possible only in a closed system at a given temperature. Yes, that is correct. You cannot have equilibrium if the system is open. Next, at equilibrium all the measurable properties of the system remain constant. Yes, that is also correct. So both statement 1 and 2 are the correct answers. Next, 11th question, match the following. Okay. Oxygen in potassium superoxide. So if you see here, what is the potassium superoxide formula? KO2. So Xi minus 2x is equal to 0. Sorry, X minus, sorry, not X, potassium is plus 1, right? Yeah. So what I can write here? 1 is equal to 2x or X is equal to 1 by 2. So what will be the charge of oxygen? 1 by 2. So A has to be 2. So you can find only these two options. So I can eliminate these two options. Next, hydrogen in metal hydrides are negative charge. So that is your B is equal to 4. So I have only one option with B is equal to 4. So option number B is the correct answer here. Next, which of the following will not show resonance? So for resonance, what is required? See, for resonance, we required conjugation. Okay. What is the meaning of conjugation? you need to have double bond, double bond, then single bond, something like this conjugation should come. Now if I draw this structure C6H6, this is the structure of C6H6. So you can find double bond, single bond, double bond, single bond. So there is conjugation. So resonance can be there. If I do C6H12, so you can draw like this. Okay. There can be different possible structures. Okay, I can also have, I think, like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, not like this. So I can have 1, 2, 3, 4, 5, 6. So C6H12 is your alkene group, right? So I'll put one alkene like this, suppose. Then I can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you don't find double bond is there, single bond is there, but after that there is no double bond, right? So you should have either double bond, single bond, double bond, or you can have double bond, single bond and then lone pair. Okay, these are the two sets of conjugation that is possible. Double bond, single bond, double bond, or double bond, single bond, lone pair of electrons. So let us see this one, CH3NO2. So it is like this, CH3NO2. You can see here, this is the structure of nitrogen, NO2 group. You can find here double bond, single bond and then one lone pair. So here also conjugation is possible or resonance is possible. C6H5COO minus. So C6H5, okay, C double bond O, O minus. Now see, this is also a kind of conjugation, double bond, single bond and a negative charge. Okay, double bond, single bond, negative charge. So this bond can shift here, this bond can shift here. So this will also show resonance, but here there is no resonance. So option number B is the correct answer here. Okay. Next, question number 13. An important property of carbon that has made carbon to be a backbone element of the organic compound. That is your both catenation and tetravalency, but catenation is something which is because the carbon can form long carbon chains. Okay. Next, spatial arrangement of atoms which can be converted into one another by rotation around a CC single bond. So when you rotate, you get different conformations. So these are called as conformers because that is not there in option, but it is also called as rotamers. Okay. Next, we have which of the following reagent will produce trans alkenes from reduction of alkynes. So we know from cis alkene you can use any of this, but for trans alkene we need sodium and liquid ammonia. Okay. Now moving to fill in the blanks questions. The element discovered by spectroscopic method is. So that element was your rubidium. Okay. So it is rubidium. Okay. Next is the electrovalence is always equal to dash on the ion. The electrovalence is also always equal to the charge of the ion. Right. Okay. Next, if Bronsted acid is a strong acid, then its conjugate base is a. So now if you see, you have some acid. Okay, what are Bronsted acids? Bronsted acids are those acids which can donate H plus, right? So this one will give you H plus and A minus. Okay, if this acid is a strong one, then its conjugate base will be a weak base. Okay, so the conjugate base will be a weak base. Okay, next what happens? The element which has the same oxidation state in all of its compound is your fluorine group. Okay, so we have fluorine, so that is your fluorine which always have an oxidation state of -1. Now the compound A contains nitrogen, but Zeldal method is not applicable to estimate the amount of nitrogen in compound. So this is because it is not present in the form of nitrogen, it is present in the form of azo compound. Okay, clear? Now we will go to 2-marker question. Okay, so you can see from question number 21, okay, from question number 21 to 30. Okay, so there are 10 questions in 2 markers and you have to attempt any 5. Okay, so you will get 5 questions, whichever you are confident you can attempt that. 5 into 2 will give you 10 marks. Okay, so let us quickly see them. Very easy questions these are there. State Heisenberg uncertainty principle. Mention any one significance of the uncertainty principle. So here whenever any principle is asked, please remember to write the statement, the formula and the symbols or the meaning of the symbols in that formula. So we know that Heisenberg in uncertainty principle tells you that simultaneously you cannot calculate the position and momentum accurately. That is your statement. So you can write Heisenberg uncertainty principle states that it is impossible to simultaneously determine both the exact position and the exact momentum of a particle with perfect accuracy. So this is the statement. Now what you have to write? Mathematically it is represented as, this is the formula, delta x is equal to delta p is greater than or equal to h by 4 pi. But here if you write only this much, this is not correct. You should also mention the terms here. So what is delta x? Delta x is uncertainty, or let me write here, I have more space. So if this is the equation, delta x into delta p is greater than or equal to h by 2 pi. Delta x is uncertainty, okay, in position, right? Okay. What is delta p? Uncertainty, you should write these terms, okay, uncertainty in momentum, okay. Next, what is h? H is your Planck's constant, okay. Next we have 2 pi, okay, that's the terms. Now what is its one application? So due to this Heisenberg principle only we can say that electrons do not have an exact trajectory, okay, they do not have fixed path to move around the nucleus, and that is why the wave nature of electron could be discovered, okay. So that is the your significance. It disapproves the classical idea of well-defined particle trajectories at the quantum scale, okay. So it is not possible to for such micro particles, okay, or such small particles to have the exact trajectory around the nucleus, okay. So question number 22, the bond angle of SO2 molecule is less than 120 degree, reduced to 119 degree, give reason. This will give you 1 mark. Mention the shape of the SO2 molecule, that will give you the 2nd mark. Now if you see SO2, sulfur has how many valence electrons? 6, right? So I can give 2 to oxygen and 2 to oxygen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we know sulfur can extend its octet. So what happens if you see the hybridization? What is the number of sigma bonds? 1, 2 and lone pair. So hybridization is 3. That means sp2. If sp2 means it has to be the shape, or sorry, the geometry must be trigonal planar, right? But what happens here now? Due to this repulsion, the molecules exist in this form. Okay, so this is called as bend molecule. So now when this, because of this repulsion there is bending, so when there is bending, this bond angle, if it would have been like this, see, for example, if the compound would have been like this, then this would have been 120 degree. But now what happens, because of there is no bond pair, there is a lone pair, there is repulsion, these two comes closer and this bond angle decreases to 119 degree. Okay, that is the first reason. Next we have, give the shape of SO2 molecule. I have already given you, it is bent molecule, you can also draw it. Okay, so due to the repulsion between the bond pairs and lone pairs, the bond angle decreases. What is the shape molecule? Bent molecule, and you have to also draw it and show it is like this. Okay, moving to question number 23. Mention 2 factors that determine the percentage of covalent character of the ionic bond. So see, the 2 factors that depends on the covalent character is the size of the ion and the polarizing power. Okay, so you can see if the cation size is small, then it will have a more covalent nature. Okay, and next one is the polarizing power of anion. Polarizing ability of anion. Okay, so if the anion can easily get polarized, then also the covalent character will be more. Okay, so you can write down size of the cation and charge of the cation. So charge will define the amount of the polarizability. Okay, next question number 24. The delta HF of Al2O3 is given. Write the thermochemical equation for the decomposition of Al2O3 into respective aluminium element and oxygen molecule. So when it is told thermochemical equation, okay, thermochemical equation means you should also mention the amount of heat that will be released or that will be required in that reaction. So if you mention that, then it is called only thermochemical equation. Now it should be a balanced equation. So if I decompose Al2O3, one second, okay, so if I decompose Al2O3, okay, so what will be the product I will be getting? I will get Al, okay, and oxygen. So if I want to balance it, so how can I balance? I can write like 3O2, 2Al2O3, okay, then this will become 4Al, 2 3s are 6, so 3 2s are 6, okay. So this is the balanced chemical equation. So now see, this is what you are breaking the molecule, means it has to be an endothermic reaction. So delta H of this reaction, okay, delta H of this reaction has to be a positive value. Why? Because it is endothermic. Now see, when the molecule was formed, this much energy was released. When you want to break the molecule, you have to provide this much amount of energy. So that is why the delta H value will be 1676 kilojoule. Okay, so that is the thermochemical equation. Here is the twist that you should be keeping in mind. When the molecule is formed, you have minus energy, right? But that is whenever a formation takes place, energy is released. But when you break the molecule, you have to provide same amount of energy. So that is plus 1676. Okay, next we'll move to question number 25. Okay, define the specific heat capacity, write the relation between Cp, Cv and R. So specific heat capacity, suppose you have 1 unit of substance, it can be 1 gram, 1 kg or 1 unit of substance, okay, and you want to raise the temperature of that substance by 1 unit or 1 degree Celsius, then we call it, or that heat required by 1 gram of a substance to raise its temperature by 1 degree Celsius is called as your specific heat capacity. Okay, then relation between Cp, Cv and R, Cp minus Cv is equal to R, but here also you should mention the terms. Okay, so what is the answer? One second, sorry. Yes, so the amount of heat required to raise the temperature of a unit of substance, or here you can also mention 1 gram of substance. Okay, here you can mention of 1 gram of a substance by 1 unit is called as specific heat capacity. Now Cp minus Cv is equal to R. So what is Cp here? Heat capacity, okay, at constant pressure. What is Cv? Heat capacity, okay, at constant volume, and R is your gas constant. Okay, next is question number 26. Plot a graph of reaction of concentration versus time for the attainment of chemical equilibrium for a reversible reaction. H2 plus I2 gives 2Hi for either direction. So you know this equilibrium reaction, so what happens, we can do like this. So this is the graph for concentration, okay, and this side it is time. So what happens with time, the reactant concentration will decrease and product concentration will increase, and at equilibrium both of them will be equal. So what I can write here is, suppose this is like this, okay, so we can, sorry, one second, okay, we have like this, yes. So this is your reactant where I can write H2 plus I2, its concentration is decreasing, and here it is Hi, okay, so its concentration is increasing. This is reactant, and this is product. Okay. Next, what are the effects of the following conditions on the equilibrium for a given reaction? So Lee-Chatterley principle, if you addition of argon gas at constant volume. So if you remember, if you add at constant volume, there is no change or there is no effect, right? So for one, what will happen? No effect. Okay. Next is, increase the pressure. So now see, if you are increasing the pressure, what according to Lee-Chatterley principle, what will the reaction try to do? Reaction will try to decrease the pressure, right? The external factor is increasing of pressure. Reaction will try to decrease the pressure. So and we know pressure is directly proportional to number of moles. So to decrease the pressure, the reaction will go towards less number of moles, right? To decrease the pressure, reaction will move towards less number of moles. Now if you see here, this side 4 moles are there, here only 2 moles are there. So reaction will go towards less number of moles or towards NH3, or I can say in the forward direction. Okay. Next, question number 28, two differences between inductive effect and electromeric effect. So you know, inductive effect is a permanent effect, electromeric effect is a temporary effect. It does not require the presence of any external reagent. Here we need some external reagent. Okay, so that is the difference I have written. You can also note down. Here permanent, temporary, external not required, external reagent is required. Okay, next, among primary, secondary and tertiary carbocation, which is most stable, and give reason. So first you have to write which is most stable, that is tertiary, and what is the reason for that? Because of hyperconjugation effect and because of plus I effect. So if you see a tertiary carbocation, it is like this. One second. This is CH3, here we have CH3, and here I have CH3. Now all these hydrogens, okay, can donate its pair of electrons to this carbon. So how many alpha hydrogens we have? Almost 9 alpha hydrogens are there. So that is why this is very stable. Apart from this, we also have plus I effect from these carbons, right? So that is why this is more stable. Okay, so what is the reason? See, first you have to write the answer, that is tertiary group. Okay, next, what is the reason? Due to the more hyperconjugation structures possible and due to plus I effect. Okay. Next, question number 30 and the last question of 2 marker section. What happens to the boiling point of isomeric alkenes with increase in branching? Give reason. First, this also you have to first explain, then give reason. So when branching happens, what happens? The the boiling point or the melting point, it actually decreases. Okay, if the branching increases, boiling point decreases. Now what is the reason for this? Now this happens because, see, suppose a long molecule was there. Now if you do branching, if that long molecule is cut and you put it in branches, that the shape of the molecule somewhat is becoming spherical. Okay, surface area decreases. So if surface area decreases, van der Waals force interaction will decrease, intermolecular force will decrease. That is why boiling point will also decrease. Okay, so you can see here boiling point decreases with the increase in branching. That's the first thing. Now branched alkanes have a more compact and spherical shape compared to their linear counterparts. Okay, if there is linear, it is like, see, suppose I have a linear chain. Okay, yeah, I have a linear chain. This is one molecule and I have another linear chain. So what will happen? These all surface area is exposed for interaction. But if I make a branched chain, just imagine this is one branch chain and this is also one branch chain. So what will happen? There will be interactions only here. Okay, so the surface area for interaction decreases, right? So that is why the boiling point also decreases. So now we'll go to 3 marker question. So from so how many 3 marker questions we have? Let's see. So from question number 31 to you have almost up to question number 40. So here also you are getting 10 questions and you have to attempt any 6. Okay, so out of 10 questions you have to attempt any 6 questions. So first is define ionization enthalpy. Mention any 2 factors that affects the ionization enthalpy. This is very common question. The most repeated question is what happens to the, what is ionization energy and what happens to the trend along the period and down the group. That is also a very common question. So ionization enthalpy, we know the energy required to remove a valence electron from an isolated gaseous and neutral atom. So please remember, you must mention these 3 terms. This is very important. Isolated, gaseous and neutral atom is called as ionization energy. That is very important. Next, what we have? Factors, you can write the effective nuclear charge and the electronic configuration. You can write about size. Okay, you can write what else factor? Effective nuclear charge, size and electronic configuration. Okay, Next, so you'll get it easily 3 marks, this carries 1 mark, this carries 2 mark. Next we have question number 32, write 3 conditions for the linear combination of atomic orbitals. This is also very simple, just you have to mention 3 conditions. The first condition is the same symmetry about the molecular axis, okay, the atomic orbitals, those who are going to combine should have same symmetry across the molecular axis. Second is they have comparable energy, and third one is the combining atomic orbitals must overlap to the maximum extent, okay, how much ever is possible, that much extent or that much overlapping should take place, okay, then only linear combination will form. Easy question, direct question. Next, using molecular orbital theory, calculate the bond order and magnetic property of C2 molecule. So first what happens here, you have to write the electronic configuration, you can draw the diagram, write the electronic configuration, then you have to calculate the bond order and explain the magnetic property. So if I do C2 molecule, okay, so I have, like, let me first draw the diagram. I have 1s, sorry, yes, I have 1s, I have 1s, then I have 2s, I have also 2s, okay, I won't get space here, let me start from little down, okay, 1 second. I'll start from here, 1s, 1s, okay. So here there is 1s, sigma 1s, and here it is sigma star 1s, okay. Next I have 2s and 2s. Here it is sigma 2s and here it is sigma star 2s, okay. Next I have 2p, okay. Here also I have 2p. So here we have pi 2px, okay, and I have sigma 2px, okay, sigma 2pz. Then this side I have pi star 2px and sigma star 2pz, okay. So here I have sigma 1s and I have sigma star 1s. Here I have sigma 2s, sigma star 2s, okay. Then I have pi 2px is equal to pi 2py, okay. Then I have sigma 2pz, okay, and pi star 2px, pi star 2py, sigma star 2pz. You don't have to draw this, but I am drawing it to show you. So carbon has a C2 molecule. Each carbon has 6 electrons, 6 plus 6, 12 electrons. So let us fill this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what is the electronic configuration I am getting? Sigma 1s, oh sorry, 1 second, I'll write below it, okay. Just a minute, yes, okay. So what's the electronic configuration? Sigma 1s 2, sigma star 1s 2, sigma 2s 2, sigma star 2s 2, okay. Next I have pi 2px 4, okay, I can write pi 2px is equal to pi 2py 2, 2, okay. So now what you want to calculate, what is the bond order? So first bond order, what is the formula? Bond order, should write the formula, okay. Half of number of electrons in bonding orbital minus number of electrons in anti-bonding orbital. So half of bonding orbital, these two are bonding, these two are bonding. So 1, 2, 3, 4, 5, 6, 7, 8 minus anti-bonding, this 2 and this 2, right? So 4. So 8 minus 4, 4 by 2 is 2. So bond order is 2. Now diamagnetic, why you can see there is no unpaired electron. So the magnetic property is diamagnetic. Here you should also explain diamagnetic because no unpaired electrons are present. Okay. Now question number 34, what is Lewis symbol? Given significance of these symbols and write the Lewis symbol structure of ozone. So Lewis symbol is what? Whenever we have any symbols where we represent the valence electrons with the help of dots, we call it as Lewis symbol. What is its significance? By seeing the valence electron, we can guess the group of the atom. Okay, so to which group in the periodic table it belongs. So that is there. So Lewis symbols are the simple notations to represent the valence electrons. Now what is its significance? It represents the number of valence electrons which help to determine the group valence. Okay. Now coming to Lewis structure of ozone. So if you want to see ozone, right? We have 3 oxygen. So I can say almost like what's the valence oxygen electronic configuration? You can write like this: 1s2, 2s2, 2p4, right? So each oxygen has 6 valence electron, 4, 5, 6. So I can say total 6 into 3, there are 18 valence electron. Now if I want to draw the Lewis structure, I will connect, I'll write 3 oxygen. Let me first connect it with, each one should be connected with a bond. So how many electrons are gone? 1, 2, 3, 4. Okay, now I want to satisfy, suppose 5, 6. I will do like this. So what you can see here, 1, 2, 3, 4, 5, 6, 7, 5, 6, 7, 8, 9, 10. I have 8, 11, 12, 13, 14, 15, 16, 17, 18. If I put like this. Now what I can observe here is, see, this octet is satisfied. This octet is also satisfied. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. But this oxygen's octet is not satisfied. So to do that, what I will do, I will make a double bond here. I will remove this and I'll put a double bond here. Okay. Now if you see 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All the oxygen octet is satisfied, right? That is the Lewis structure of ozone. You can see here. Okay. Next, question number 35. In the following redox reaction, 2Fe plus 2HCl give FeCl2 plus H2. What is the oxidation number of iron in FeCl2? This is very easy to calculate, right? Let it be X. Chlorine is -1, 2 chlorine will be -2, that is equal to 0, X is equal to +2. Okay. Next, what type of redox reaction it is? What type of redox reaction? So basically, if you see what is happening, Fe is replacing this hydrogen, right? Or non-metal replacement is happening. So it is a type of non-metal displacement reaction. Next, identify the species undergoing oxidation. So if you see Fe oxidation numbers changes from 0 to +2, right? So Fe is undergoing oxidation. Okay. So non-metal displacement, then you have +2 here and Fe. Okay, simple question. Next, moving towards what is the molecular formula, how is it related to empirical formula. Next, give an example for a compound whose empirical formula and molecular formula are same. Okay, so first of all you have to write what is molecular formula. So I will tell you the definition of both. An empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas the molecular formula shows the exact number of different types of atoms present in a molecule of a compound. I'll give a simple example. Let us talk about glucose. So in glucose we have, this is a formula of glucose, right? Now here what happens, in glucose there are 6 carbon, 12 hydrogen and 6 oxygen. Now if you take a ratio of these atoms, then what I'll get, just divide it, CH2O. Okay, so this tells you what the ratio of the atoms present in of carbon, hydrogen and oxygen. So the ratio is like this, of carbon, hydrogen and oxygen, 1:2:1. Okay, so this ratio is given by empirical formula, whereas the exact formula is given by the molecular formula. Okay, now the question is what is it? How is it related to empirical formula? So you can write down molecular formula, okay, is equal to empirical formula into N. What is this N? Where N is equal to molecular mass divided by empirical formula mass. Okay, clear? Fine. Now next is any molecule whose empirical formula and molecular formula same. You can take this example of sucrose, C12H22O11. You can take carbon dioxide, you can take water, you can take anything where there is no common factor. Okay, you can take NH3, NO2, these all will work. Okay, fine. Now let's move 37 question. A neutral atom has 2 electrons, 8 electrons and 6 electrons in K, L, M, N. Okay, so you have like this K, L and M. Okay, so you have 2 electrons, then 8 electrons and 6 electrons. Okay, from this predict its atomic number, total number of S electrons and total number of P electrons. So if I add these all electrons, I'll get 16 electrons, right? So that means 16 protons will also be there. So the atomic number is 16. If I want to write the electronic configuration, it is 1s2, 2s2, okay, 2p6, then 3s2, then 3p, 6, 7, 8, 9, 10, 11, 12, 3p4. Okay, this is the configuration. Now how many s electrons are there? So it is 6. How many p electrons are there? 6 plus 4, 10. Okay, so that is what you have to do here. Next, question number 38. When Gibbs equation, write Gibbs equation to give the relation between free energy change, enthalpy change and entropy change. This is a very simple formula. Delta G is equal to delta H minus T delta S. Now, what are the conditions for delta H and delta S for a reaction to be spontaneous and at any temperature? So, for a reaction to be spontaneous, what should be the condition? Delta G value should be negative. Okay. So, now if you put delta G negative, okay, and see, this is the equation, right? Okay. So, if my delta H is negative plus my delta S is positive, okay. So, minus T, and this is a positive number. So, you are adding two negative numbers, right? Now, addition of two negative numbers will also be a negative. So, what is the condition? H should be negative, S should be positive. Okay. So, this is the equation, and the condition for reaction to be spontaneous at all temperature is delta H has to be negative and delta S has to be positive. Okay. Next, what a buffer solution? Give an example of neutral buffer. Write the Hazelberg equation for the calculate of pH of an acidic buffer. Direct question. Buffer solutions are those solutions which can resist the change in pH, right, on addition of a small amount of acid or base. Now, neutral buffer you can make by taking a weak base and a weak salt. Then we can write the equation. So, the solutions which resist the change in the pH on dilution or with addition of small amount of acids or alkalis are called as buffer solutions. Now, example is acetic acid, that is CH3COOH plus ammonium hydroxide, that is NH4OH. Okay. Now, if you write the Henderson equation for this one, you will get pH is equal to pKa plus log of concentration of salt by concentration of acid. Okay. Then next we'll move to question number 40. For the following figures, predict the direction of reaction. This is very simple. Reaction quiescent and equilibrium constant is given. In this, reaction quiescent is less than equilibrium constant. So, this has to increase, right? So, if this has to increase, reaction will go in forward direction. Okay. Now, here QC is more than Kc. So, it has to decrease, right? So, to decrease, it has to go in backward direction. Okay. Now, here QC and Kc are equal. So, the reaction is already at equilibrium. Clear? Okay. Now, we will move to 5-marker questions. So, there are 3 5-marker questions and you have to attempt any 2. Okay. The first question is for the compound, it is given, write the IUPAC name and the bond line formula. Identify the functional group. So, if I want to write the IUPAC name, if I draw the structure, it is like this, right? CH, ClCl, CH2, CH2, OH. Okay. 1, 2, 3. So, you can write it like 3,3-dichloro. Okay. 3,3-dichloro propane 1OL. Okay, this is there. Next, the bond line formula, if you want to draw, it is like 1, 2, 3. So, I will draw 1 carbon here. So, this is OH. This is the first carbon, second carbon and third carbon. In the second and third carbon, I have chlorine atoms, right? 1, 2 and 3. This is the bond line formula. Next, suggest a method to separate. Okay, identify the functional group. What are the functional groups? Here we have an alcohol group and we have halogens group, right? So, what are the functional groups present? Alcohols and halogens. Okay, so this will give you 1 mark, 1 mark, half of 1 mark. So, total 3 marks. Next, how will you separate 2 immiscible liquids? By using separating funnel. A mixture of plant pigment by using chromatography. Okay, so that answer I have given you. This bond line formula, I will do it once again. Okay, 1, 2, 3. Clear? Okay, next we'll move to question number 42. Complete the following reactions. So these are oxidation reactions given. So if you convert CH4 with O2 at what I'll say, copper at 524 Kelvin and 100 atm, you will get alcohols. If you convert it with MO2O3, you will get aldehydes. If you convert it with CH3COMn, you will get acid. Okay, next explain reforming reaction with a suitable example. Now this question actually I can say is a very tricky question, because this word reforming is not mentioned in your NCERT book, but the reaction it is already given. So what is a reforming reaction? Reforming reactions are those reactions in which an alkane can get converted to an aromatic compound. Okay, an alkane, or you can say a hydrocarbon or an aliphatic chain, okay, gets converted to aromatic ring. Okay, that is called as your reforming reaction. Okay, so now let us see the answer quickly. Okay, so CH3OH first one, then you will get aldehyde, the second one is CH3COOH. Now conversion of alkanes to aromatic hydrocarbons is called as reformation or reforming reaction, and you have this reaction where you can take hexane or N-hexane in presence of Cr2O3 or V2O5 or MO2O3 at this temperature and pressure, and that will get converted to benzene. Okay, so please remember what is reforming reaction. This is important. Let's see question number 43 here. Write the mechanism of chlorination of benzene, define polymerization and mention any one use of polymer. Okay, so let's talk about what is chlorination of benzene. If I just write down the reaction, what is that? You have benzene, and if you just take Cl2 in presence of FeCl3, or better we can use AlCl3. Okay, any Lewis acid you use, okay, you will get chlorine will be attached to benzene ring. Okay, now what are the steps for that? So step number 1 here is generation of electrophile. Okay, so you have Cl2 plus you react it with AlCl3, you will get Cl plus and AlCl4 minus. Now what is step number 2 here? Step number 2 is, I can say, what is it? Generation of, or you can write formation of carbocation. Okay, I'll change the word generation. I'll write here formation. Okay, so what is this reaction? You have this benzene ring. Okay, H are available. Okay, and now you are having Cl plus in this. So what will happen? This one will attack here. Okay, so what I will get here? I will have H. Yes. Here one Cl will be attached, and we will have one positive charge. Okay. Now after this, what happens? You can write down step number 3. Okay, that is regain of aromaticity or loss of hydrogen. Also you can write loss of proton, deprotonation. Okay, so here what happens? I have this structure right at the end. See this structure I have. I'm just writing like this. This part I am writing H plus and Cl. So this bond will come here. Oh, sorry, one second. I will write like this. I'll keep Cl here and H here so that I can explain you correctly. This H will come here. Okay, this bond will come here and H plus will go out. So what will be forming here? Chlorobenzene. Okay, that is the mechanism. Now what is polymerization, and mention one of its use. So when large number of molecules combines under high temperature and high pressure in the presence of a catalyst, it is called as polymerization. What is its use? It is used in many places, like in the manufacture of plastic bags, bottles, refrigerator, dishes, toy, pipes, everything you have that is made up of polymers. Okay, so with this the I'll say what is completed. The 5 marker questions are completed. Now we are moving towards part E. Okay, so here, oh, one second, sorry, these are 4 marker questions. Okay, sorry, not 5 marker, these are 4 marker questions. Okay, so you have to attempt any 3. Okay, any 3 questions you have to attempt, and there are, I think, 4 questions are there, you have to attempt any 3. Now naturally occurring chlorine consists of 2 atomic weights 34.9 and 39.5, and their abundance are given. Calculate the relative weight of chlorine. So this is very simple. We have this formula, relative weight, you can write down, relative weight is equal to isotope 1, okay, sorry, M1, I can write like this, mass of first isotope, okay, mass of isotope 1 into the abundance, okay, plus mass of isotope 2 into abundance, okay, divided by 100. So now what will give you, what you will form here, isotope 1 is 34.9, okay, into 75.6. you will have calculator, so you can easily do this calculation, no problem. Then I will get 39.5, okay, into, I have 75.6, no sorry, 24.24, okay, this is 24.24 divided by 100. So if you solve this, you will get the mass relative abundance, which is around 36.25. okay. Next, question number 45. Calculate the energy of 1 mole of photon of radiation whose frequency is given. 1 mole of photon. So first we'll calculate of 1 photon, then we'll calculate for 1 mole of photon. Okay. So if you have like E is equal to h nu. Okay. So that is the energy of 1 photon. What is h value? I can put 6.6 into 10 to the power of minus 34 into, I'll get 5 into 10 to the power of 14. Okay, so how much I'll get? 5 6 are 30, 33, right? 33.0 into 10 to the power of minus 20. This is there. Now I want to calculate for energy of 1 mole. Okay, so that means what? This is of 1 photon, so 33.0 into 10 to the power of minus 20 into 6 into 10 to the power of 23. Okay, this is for 1 mole. So if I multiply here, 6 3s are 18, 18 plus 1 19, so 198, okay, into 10 to the power of 3. Okay, that is the energy. So you can write it in the form of 1.98 into 10 to the power of 5. Okay, clear? Okay, so this answer is only up to this one, then you have to do this part as well. Okay, next question number 46. The combustion of 1 mole of benzene at 298 Kelvin and 1 atm liberates this much amount of heat. Okay, calculate the standard enthalpy of formation of benzene. The standard enthalpies of formation of CO2 and H2O are given. Okay, so now you see here, combustion of 1 mole of benzene is given. So if I want to the combustion of 1 mole of benzene is taking place. Okay, so what will be the product here? CO2 plus H2O. Now if I want to balance this reaction, I will have 6 CO2 and I have 3 H2O. So how many oxygen? 3 oxygen. No, sorry, 6 2s are 12, 13, 14, 15. So 15 by 2 oxygen. Okay. Now what is the value of this reaction? Energy liberated is minus 3267, right? So what is delta H here? See, this one, if you do not put minus, you will get wrong. Okay, so because see, the energy liberated means energy is released, so the energy value has to be negative. Okay, so this is the value. Now this you have, if you don't put negative, this will get wrong. Now for what we have to calculate? Enthalpy of formation. Calculate the standard enthalpy of formation of benzene. You want to form benzene. So if I want to form benzene, so what will be that reaction? I'll write it in different color, the required equation. Okay, so this will be what? You want to form this one, so I will have 6 carbon plus 3 hydrogen. Okay, that will give me, and for this one the reaction value I have to calculate. Now what is the values given? Enthalpies of formation of carbon dioxide and water. So you have been given with the enthalpies of formation of carbon dioxide. How will this one form? C plus O2 and water, right? If water you want to form, so what will be the reaction here? H2 plus half O2. Okay, so now CO2 value is how much? I will write it in this color. So that is your minus 393.5. Okay, and then you have minus 285.83. Okay, these are the values. You have to calculate for this value. Now if you see, this is very important and easy question as well, but you should do it carefully. Now see, in this required equation I need 6 carbon. In this equation I have carbon, right? But I have only 1 carbon. So what I have to do? I have to multiply this equation with 6. So if I multiply that, what will I get? 6C, 6O2, 6CO2 into 6. Okay. Next I need 3H2. There is only 1 H2, so I will make it 3H2, 3H2, 3 by 2 O2, 3H2O into 3. Okay. Now you see, in the required reaction I required C6H6. In this reaction C6H6 is there, but it is on the opposite side. So what I will do, first I will add these two reactions. Okay, let me add these two reactions and tell you what value we are getting. So if I add these two reactions, so what I will get is, one second, yes, see, so I will get 6C plus 3H2 plus 15 by 2 O2 gives me 6 CO2, okay, plus 3 H2O. Okay, this is the reaction after adding this one. I also want to add these two values, so let me multiply here 6 into this one. 6 5s are 30, so this is 3 carried 3, 6 is 18, 19, 20, 21, 654 plus 256, 6 is 18 plus 5, 23. Okay, so I'll put one decimal here. Next, if I multiply here, 3 3s are 9, 24, 17, 25, 8. Okay, this is the value I'm getting. Now what I'll do, I'll add these two equations. So it is minus 236 1.0. Then I have another is 857, okay, 0.49. So I'll get 49, 12, 3. 3218.49. Okay, what is the value of this one? Minus 3218.49. Okay, so I'll erase this part, this calculation part. Okay, now what is there? See, now if I add this first reaction, okay, to this reaction, but I will reverse this reaction. So what I will add? See, one second, let me write down this value here. Minus 3218.49. Now reverse the given reaction, what I will get? 6 CO2, okay, plus 3 water, okay, this one will give me C6H6 plus 15 by 2 O2. Okay, now we can cancel the common terms. If you cancel the common term, 6C and sorry, not 6C, 6CO2, 6CO2 will get cancelled, 3H2O, 3H2O, 15 by 2, 15 by 2 O2 will cancel. What is left in the reaction? Okay, when I reverse this reaction, what value I got? Plus 3267. Okay, now you see, if I add these two reactions, so what I am getting here is 6C plus 3H2 gives me C6H6. Okay, balanced reaction. Now you also have to add these two value, so I can just subtract this one, like 3267.00 and 3218.49. so 10 minus 9 1, 9 minus 4 5, 17 minus 8, so 9, 5 minus 1 4, 49.51 I'll get. Okay, plus 49.51 will be the answer for this question. Okay. I hope all of you have got this. It is little tricky, not tricky actually, lengthy question, but yes, very scoring. You should be very careful while solving this question. Okay, 49.51 will be the answer. 48. Okay, check this calculation once again. Okay, 48 or 49 I am getting. I have to subtract from here, right? 16 minus 8. Okay, this one 16 minus 8 will be 8. Okay, 48.51. Okay. Next we'll go to next question. The value of Kp for the reaction is given and PCO2 is given, PCO is given, and you have to calculate the pressure of CO. Okay, this is very simple question. I have this reaction, right? CO2 plus C gives 2CO. In this is gas, this is solid, and this is gas. What's the value of Kp? Kp value is pressure of CO square. This is solid, so you can leave it, pressure of CO2. Now what is the value of Kp? Kp value is 3. Okay, pressure of CO is 0. No, sorry, pressure of CO we have to find out. Sorry, one second. This is okay, one second. This is actually pressure of C. Okay, not CO. This is pressure of C because it is a solid one. So what will I'll get? Did I change the color? No. Okay. So what I'll get, 3 is equal to pressure of CO. Yes. Pressure of, oh my god. Okay. We'll get pressure of CO. Okay. Divided by P of CO2. P of CO2 is given how much? 0.48. Okay. And this is square is there. So if I multiply this one, 3 8s are 24. So I can say 141.44 is equal to P of CO, and square root is there. So if you take square root, it will become 1.2. Okay, answer is 1.2 bar here. Okay, very simple and easy question. Next, last question. In Carrier's method of estimation of sulfur, 0.466 gram of barium sulfate formed 0.32 gram of organic compound. Calculate the percentage of sulfur. Molar masses are given. Okay, so what is our formula to calculate the percentage of sulfur using Carrier's method is 32 by 233 into mass of the barium sulfate by mass of organic compound into 100. So if I just want to substitute this value, I will get 32 by 233 into, what is the mass of barium sulfate? 0.466. What is the mass of organic compound? 0.32. Okay, into 100. Okay, so now how can we solve it easily? Look, very easy numbers are given. See, 32 by 233, decimal I can write 466. Okay, by 1000. Okay, into 32 I can write 100, and this one is 100. So 32 will get cancelled, this one will be 2, this one, and I can cancel this one, so I'll get 20%. Okay, so answer will be 20%. Okay, so that's all students, and I hope that you have understood all the solutions. If you have any doubt in any question, you can comment down. And one more thing, we are coming up with many more things for your first year pre-board examination. So please do not forget to subscribe the channel. We are going to give you one-shot revision videos, the most important questions, everything will be done for you. So please stop your complaints, like your requests also have been taken. So please subscribe the channel.